I'm going to show you the procedure of executing a program in Keil simulator. So before going to start this, let us have an idea about what is the Keil program and what is meant by a target. Okay, what is meant by a target? So a target means, so I'm going to design, take an example. I'm going to design an LCD display. I'm going to interface one LCD unit to the microcontroller. My intention is to display Sainik Puri or some text on this particular display unit. So in order to display the text, I will write a code in Keil simulator, and I will generate one hexa file. That hexa file I'll put it in this particular microcontroller. So this is what is my target. So my target is going to be a microcontroller, which is an 8-bit microcontroller. In this particular application, I'm using this microcontroller to display some string on the LCD unit. Okay, so let me show you. I have written one particular program. I have written one particular program, that is LCD interfacing.h. Okay, in this particular ROM, in the ROM of this particular microcontroller. Okay, that interfacing.h file is generated using the simulator. That simulator, that hexa file I'm dumping in this particular microcontroller. This microcontroller, upon executing, upon switching on the microcontroller, so what happens is it will display whatever I want on the display unit. Okay, so this microcontroller is going to be my target. Target may change from one application to another application. So in this particular application, my target is 8051 microcontroller. So let us start with what the programming procedure of how to simulate a program, how to execute a program using Keil simulator. So after I have installed the Keil simulator in my system. So double click on this, and then the environment will be open. The first step is go to project and close the project. Project is nothing but a folder. Project is nothing but a folder which may contain one or more than one ASM files. ASM file means assembly level language program files. So first you have to create a project, and then to that particular project we will add the ASM files. Now how to create a project? So go to project, click on new project. It's not compulsory to create new project every time. So let us suppose you can use the same project by adding one ASM file and executing it, and then remove it, add another ASM file and execute it. Like that, you can use the same project, but you can change the ASM files that you want to execute. So file name. So give the project name. So this is my Keil demo, Keil demo files, demo project, project, or give, you can give final year electronics project. Okay, so you can create it and click on save. Click on save. Now you have to select the target. I told you earlier. So my target in this particular application is an 8051 microcontroller. Is an 8051 microcontroller, ATC51. So I will choose ATC51, which is manufactured by a particular manufacturer like Intel. So I'll go with Intel. So and then expand it 8051 AH or 80C51 like that. You can choose any microcontroller. Depends on your application. In your application, your target is, I mean, in this particular application, you are using 8051. So I have to write code which is compatible to this microcontroller. So 8051 AH and then say OK. Then say OK. Copy standard 8051 startup code to project folder, add file to project. So whether you add whether you say yes or no doesn't matter. If you click on yes, some extra files will be added. If you say no, doesn't matter. Okay, so click on no. Then expand this, click on plus. Now then you go to file. Now your folder is ready. You just have to add one ASM file. To this. So what I do is I'll go to this particular folder. I'm creating one new text document. So I'm naming first ASM file per addition file, first program. That file should have an extension of .asm. Project should have, don't worry about the extension of the project, but the assembler file should have an extension of .asm. Okay, it is asking me to change the file extension. The file may contain unsafe or unusable, or you want to change it or something like that. It is asking me. So you say yes. Okay. So what I have done is I just have created an ASM file in a required folder. So then okay. So then you come to source group one. Okay, and then here also. So there are two ways to create one ASM file. One is to create it here, just like the method what I have shown you just now. That is one method. The other method is you directly go to file. And create new. Create new, and then click on save. And you give SECO and the second program .asm program.asm. You give second program.asm as the file name and then click on save. Click on save. So the first method is you can create it outside the simulator. The other one is you can create it inside this particular simulator by clicking on file and then new. You can save this as so file name dot asm. Okay, so if you don't save, it will ask you you don't want to save or not. If you say save, you just have to give the name. The main thing you have to remember is you just have to give the file name followed by the extension .asm. So after that, what you do is you want to simulate the first program. What is the purpose of the first program? So write an assembly language program to accept two numbers into registers and perform arithmetic addition and subtraction. You want to perform arithmetic and subtraction of this program you want to write. You want to simulate this. So I already have given the programs for all, means the code for all the all those programs in the which are there in the question bank. Okay, copy down the first program and then paste it here. Okay, so I just have copied the first program. So I don't want this line to come in the execution. So what I do is I put semicolon. I'll put semicolon in that. Semicolon means comment. Semicolon means comment. For your convenience, I'm just copying the same program. Okay, and uh, editing it here. Later, I'll put it in that simulator. So what is the first program? So first program is to write an assembly language program to accept two numbers into two registers and perform arithmetic addition and subtraction. So I don't want to consider this in the execution of the program. So you may comment this by, you may make that as a comment by putting two forward slashes or else one semicolon. Okay, so now this is what is the directive. This is what is the directive. This is another directive. So the meaning of this is to start the program from 00 location onwards. ORG is a directive which will direct the assembler, which will guide the assembler to start the program from 00 location onwards. So MOV A comma 0, MOV A comma hash 06. So the meaning of this is initialize A with 06H. If you put H, that means that 6 is a hexadecimal number. If you don't put H, that means it is a decimal number. Now let us suppose if I write 0101B. Okay, so like if I put 00000101B, B means binary. Okay, B means binary. If I write 06O, O means octal, O means octal, H means hexa, B means binary. And if you don't put anything like if you don't write H or O or B, then that number is a decimal number. So the first line is I'm taking 6 in accumulator and transferring it in R1 register. R1, I'm sending a value. Move R1 comma A means whatever is there in A that will go into R1. Okay. Now move B comma 05H. So nothing but initializing B with 05H. Now add A comma B. The purpose of this instruction is to add A value with the B value and the result will come in accumulator. So this is an arithmetic instruction. So this affects the flags. There are various flags are available like carry flag, auxiliary carry flag, and the parity flag, so like that. So these are the mathematical flags mainly. So these flags will be affected upon executing this add A comma B. So after the execution of this particular instruction, so move R0 comma A means whatever is there in A that will come into R0 register. That will come into R0 register. So what I've done here is I just have taken 6 in A, 5 in B, and then added, and I'm storing that result in R0 register. Again, move A comma R1. The first number is there in A. The first number is there in A. So that I shifted that one into R1. Now, as I was asked to write an assembly language program perform addition as well as subtraction with the same numbers. So I'm taking the first number, I'm accessing the first number again from R1 register. Move R1 comma A. Move R1 comma A means whatever is there in R1 that will come into accumulator. So CLRC means carry flag will be cleared. Carry flag will be cleared. So now SUBB A comma B means A is equals to A is equal to A minus B minus carry flag. So here the carry flag is cleared. So A is equal to A minus B minus carry flag. So like what is the first number? what is there in accumulator? Accumulator is having six. Accumulator is having 6. And what is the D register is having? B register is having 5. And the carry flag is cleared, which means 0. 6 minus 5 minus 0 is 1. So after the execution of sub A comma B, so 1 will be there in the accumulator. If you don't clear the carry flag, so let us suppose if the carry flag is 1 without your, if you don't clear that, so that may affect your subtraction. You may not be getting the exact result if you don't use the CLRC. Now, after the subtraction, the result is there in A. I am shifting that A value into R2 register, Okay, and S jump means short jump, which is a branching instruction. This is just like stop, halt of the halt instruction. So S jump stop is the label name given to the memory location. It will jump from here to here, then it will come here, then it will just like this is nothing but end of the program. This is nothing but the end of the program. Okay, so end. The next one is end, which is a directive. As I already told you, org, end, they are directives. They are not instructions. They are apart from instructions. These two will guide the assembler to consider 00 as the starting address, and this is the end of this particular program. So that it will convey by writing this. So I'm copying this and pasting it here itself. Okay, pasting it here itself. Okay. So after that, so this file, this particular ASM will save it. Okay. This ASM file is not attached to your project. So it is not attached to your project. The project is somewhere and this ASM file is somewhere. There is no link between your ASM file and the project. So establish a link between, add this ASM file to your project. So how? You right click on this source group and then click on add files to source group and go to the folder where you have saved this and click on file type as ASM file. So this is what is the second program. I'm just clicking on second program and then say add and then say add. So once if you click on add, so this particular ASM file will be, this ASM file will be added to your project. ASM file will be added to your project. Okay, so after that, you have to use three things. Uh, one is build, rebuild, and translate. So you go to project, click on build, click on build. It will check whether there are any errors or else any warnings are there in the program. If the errors are there, then it will show you where that error is. Okay, and then go to rebuild, and then click on translate. So if you click on this three things, it will check each and every line of the program. If there are any errors are there, if everything is fine, it will show you zero errors and zero warnings, zero errors and zero warnings. So this is how we have successfully simulated a file. How to see the result? How to see the result? You go to debug, click on debug. After pressing build, rebuild, and translate, you go to debug and click on start or stop. Okay, so evaluation version, which is the limited version, say if the code length is less than 2K, then this particular program will be executed successfully without any errors. Otherwise, it will not execute. Okay, now this is what is the program. So here you can see here R0, R1, R2, R3, R4, R5, R6, and R7. A means accumulator, B means B register, SP is the stack pointer, Okay, DPTR is a data pointer, PC is the program counter, and PSW is nothing but the program status word. Okay, if you expand this PSW, P means parity flag, overflow flag, register select, and auxiliary carry flag and the carry flag. The flags, you can see the status of the flags very clearly here. Okay, now you click on debug and then step. If you want to execute the entire program in one single go, then you press run. Okay, step means, so this particular line is executed. Upon the execution of the first line, what happens is, upon the execution of the first line, accumulator will be loaded with 5. Let us see accumulator is loaded with 5, 6 or not. So accumulator is loaded with 6. Okay, now click on next. Click on next. Okay, so what happened is, upon the execution of this, whatever is there in A, that is 6, that will come into R1. Upon the execution of this, B will be loaded with 5. Okay, so you can see here R1 is loaded with 5 and press next. So upon execution of this instruction, B is loaded with 5. Now add A comma B, A plus B, 6 plus 5 is 6 plus 5 is 11. That result will come in accumulator. Now I'm clicking on step into or go to debug and then step, right? So 6 plus 5 is 11. 11 is nothing but 0. B. 0 B means 11. Then move R naught comma A. This is R naught. It is having 0. The moment you press step into, this 11 will come into R naught value. Move A comma R1. Whatever is there in R1, that will come into A. Move R1 comma A comma R1. Whatever is there in R1, that will come into A. Okay. So whatever is there in R1, that has come into R1. Clear C. Clear C. So you can see the carry flag status clearly here. Okay. So if you click on this, the carry flag will be cleared. Sub BAB, SUBB. A is 6, B is 5. 6 minus 5 is 1. You click on run. 6 minus 5 is 1. So move R2 comma A. Whatever is there in A, you move it into R2. Okay, so click on this. So that 1 has come into R2 register. So this is the end of the program. The cursor will not move ahead. The cursor will not move ahead from this particular line because you are keep on asking the microcontroller to execute the same instruction, nothing but end of the program, halt of the program. Okay, so there is one more window I want to show it to you. So that is view disassembly window. There is a window called as view disassembly window. Disassembly window means, so this is what is the disassembled version of the same program. Okay, so here 7406 is the code of move a comma 06. F9 is the code of move r1 comma a. So 75F005 is a code of move B comma 05. So like this window is a disassembled window. Okay, so you can switch from one window to another window. So with these two tabs, okay, this is how we execute a program, and we stop after the execution is over, we stop it. Okay, so once again, you can you can if you want to remove the project, you just go to select this and right click on this, remove the file .asm. All right, now you want to add means you right click, again click on add files to source group and select the file type as asm, then click on asm, then add. Okay, so like this you can add your source file asm file to your project. So this is the procedure of executing a program, executing the program in the Keil simulator. So there is one more window that I want to show you, that is code window. Code window. That is, it's like this. You go to view. Okay, during the run execution. So go to debug and start. That code window you will see only during the execution of the program. Okay, so view code window. Okay, or memory window. You click on memory window. So this is the memory window. You click on this, the memory get disappeared. So click on memory window. So you want to see what is there in eighth location, internal memory location. So I colon I colon 05H. So means so like this memory location contents can be accessed using this particular window. So I'll stop it here itself. Thank you very much.